You didn't want to go, I asked him. Honestly, I don't blame him. The living for was funny.
Okay, the only difference between what you guys learn on Friday and what you guys are going to learn today is now you guys are going to be given the initial condition. So we've kind of already done this already, but just these problems are a little bit harder than what you guys have done yet. All right, so it says find the solution to the differential equation dy dx is equal to xy squared with initial condition y of 1 is equal to 1. So sometimes they'll give you guys a point, and then sometimes they'll write it like this. So if y of 1 equals 1, this is really your x, and this is really your y. Okay, so just don't forget that. What was the strategy that we would use? What was that phrase I used on Friday? It's in the title of the section from Friday. Separation of variables. So I need to get all the y's on one side, all the x's on one side. But you guys see how this is xy squared? So they're trying to trick you. So what you should do is you guys should rewrite this so that way we can separate them. So I'm going to write it like this. dy dx is equal to, if I square this, it's going to be x squared y squared. So if I want to get all the y's on one side, I can divide both sides by y squared, which is the same thing as multiplying this side by 1 over y squared. Is everybody cool with that? And then what can I do to get the dx to the other side? Multiply by dx. So if I multiply this side by dx, multiply this side by dx, then the dx will cancel. So then I'm left with 1 over y squared dy is equal to x squared dx. Okay. What's the next step? Take the integral. Now this right here, guys, you guys agree is the same thing as y to the negative 2? So if I do the antiderivative, it's going to be y to the negative 1 divided by negative 1, which I could just write like that. Does that make sense? Is equal to, what's the antiderivative of x squared? X cubed over 3. Don't forget your plus c. Okay, now here's the cool part. You really want y by itself. Didn't we do that on Friday? But before we do that, sometimes it's easier once you get here, plug in your initial condition, and then later on solve for y. So what I'm going to do is, we know that y of 1 is equal to 1, right? So I'm going to plug in x and y right here. So then I have negative 1 to the negative 1 is equal to 1 cubed over 3 plus c. What does the negative 1 power really mean? Reciprocal, right? Anything to the first power, does it change? So this is going to be just like negative 1 over 1, which is just negative 1, is equal to 1/3 plus c. Subtract 1/3 from both sides, and we get negative 4/3 is equal to c. Okay. Now I told you guys this is going to get hard, right? Harder. So this is where things get weird. Check this out. I know my c now, so I can rewrite this as, I'm going to write this as just negative 1 over y. So negative 1 over y, because it means the same thing, is equal to x cubed over 3 plus 4, or minus 4/3, excuse me. So do you guys see how these have the same denominator? So I could write this as negative 1 over y is equal to x cubed minus 4 all over 3. How can I get rid of the negative? What? I can multiply both sides by negative 1. So then 1 over y is equal to, if I multiply both sides by negative 1, I could write it like this, 4 minus x cubed over 3, because I'm just changing the signs at the top. Now, I can't leave it like this, so what was the thing that I showed you guys on Friday I need to do? Take the reciprocal, good. So that means that I could say now that y is equal to 3 all over 4 minus x cubed. So whenever the directions say this phrase, this is what you're doing. We got the final equation, right? This is called the particular solution. On Friday, what were we finding? The general solution. So that means all of the plus c's. So this represents a slope field. This represents a slope field, bless you. We found one solution given this point, okay? If you guys look on the algebras, they actually graph this on a slope field. I'm not gonna make you guys do that because we'll see one when we practice for the AP test, but if you guys have to actually graph a slope field, it's not as bad as the ones they're making you guys do. I looked at the video that they made and some of the problems they're gonna have you guys do, I'm like, that's way too complicated. Nope. So I'm not gonna make you guys do it. All right, example 2. Find the solution y is equal to f of x to the differential equation dy dx is equal to 2x over y with initial condition f of 2 is equal to 1. Good morning. So remember, this is your x, this is your y. So separate the variables. So how am I going to get y to the other side? Multiply both sides by y. How can I get dx to the other side? Multiply by dx. So y dy is equal to 2x dx. Now, I've talked to some of you guys about this. Make sure that you guys are writing your dy's and dx's. Please don't lose silly points on the AP exam. Okay? If you guys think I'm being mean, just wait till you guys get to college. Some of your professors, when I took my physics class, I'm pretty sure I've told you guys this story. I'm like scarred for life because my professor was super hardcore. She would give us 4 problems, you guys. 4 problems worth 100 points. So how many points is each question worth? 25 points each. If you made one mistake, she gave you a 0 on the problem. That's like hardcore. So like, I don't do that to you guys, but some professors could do that. We'll talk about college later. What do I do next? Take the integral. Okay. What is the antiderivative of y? Y squared over 2. What's the antiderivative of 2x? X squared, and don't forget your plus c. Okay, this would be a good time, guys, to plug in your initial condition. Okay, so what was my initial condition? What am I going to plug in for x? 2. And what am I going to plug in for y? 1. Wait, is that right? Did I do this right? I'm not going to get the same thing. Okay. We're not going to do that yet. JK. Multiply both sides by 2 first. Because if I do what I just told you guys, you don't get the same answer. Y squared is equal to 2x squared plus c. Now plug in your initial condition. So y is, what was y? 1? So 1 squared is equal to 2 times 2 squared plus c. So 1 is equal to 2 times 4 plus c. This is just 8, right? So if I subtract it to the other side, what's c? -7. Okay, so this is the weird part. And we didn't talk about this on Friday, so pay attention. We know what c is now, right, guys? What's the last thing I need to do to get y by itself? Take the square root. So y is equal to plus or minus the square root of 2x squared minus 7. However, which one is it? Is it? So here's how you know. Look at your initial condition. Okay? So which one of these is going to give me positive 1? Can the square root of something ever be negative? No. So if this was a negative, does it make sense that if this was a negative on the outside, it would change that to negative? So whenever you get something like this, you have to check your initial condition again. Okay, so because this is positive, that means that we want the positive. So that means our equation is y is equal to the square root positive of 2x squared minus 7. Okay? Questions? This is a really weird one. So separate your variables. So do you guys see how I have things with y already separate from things with x? So if I want to move the y to the other side, I can divide both sides by y plus 2. And then this will cancel. And then if you guys are following along, I can just multiply both sides by dx at the same time, right? So what am I going to write on the left side? 1 over y plus 2, good, dy is equal to e to the x dx. Please show this next step. What do you need to do next? Take the integral. All right. If this was just 1 over y, what's the antiderivative? ln. Do you guys see how it's not 2y or 3y, it's just y? So you can do u sub right here, but you don't need to because there's no coefficient right here, it's just 1. So this is just the natural log of the absolute value of y plus 2 is equal to, what's the antiderivative of e to the x? Just e to the x, and don't forget your plus c. All right. Now, things are going to get really weird right here. Before we figure out what y is, let's go ahead and plug in our initial condition. Okay? So what am I plugging in for x? 0. And what am I plugging in for y? 1. 1? Negative 1. Did I write 1? Oh, it's supposed to be negative 1. I was making sure you guys are paying attention. Let me actually fix that real quick before next year. I'm going to forget. Okay. What is 2 plus negative 1 on the inside of the absolute value? 1. What is the ln of 1? That's just going to be 0. What's e to the 0? 1 plus c. So 0 is equal to 1 plus c. So what's c? Negative 1. Okay, so now since we know c is negative 1, I'm going to plug it back into here, and I need to solve for y. So the natural log of the absolute value of y plus 2 is equal to e to the x minus 1. So guys, what do I need to do? How do I get rid of the ln? E. So remember I told you guys be dramatic? So put a big base E on both sides. So this is why I told you guys it's going to look weird. Do you guys see this? This? That looks weird, huh? But that is technically right. So watch what happens. E and ln cancel. So we have the absolute value of y plus 2 is equal to e raised to the ex minus 1. Okay. Now, we did not talk about this on Friday because we're just finding general solutions. How do you solve something that's absolute value? This goes back, guys, to math 1. Yes. So don't write this down, just watch. If I gave you guys something like absolute value of x plus 2 is equal to 3. In math 1, you guys would do this. X plus 2 equals 3, or x plus 2 is equal to negative 3. And you would solve both cases. Does that look familiar from a long time ago? So because of this, that means that y plus 2 is equal to plus or minus all of this, okay? So that means y plus 2 is equal to plus or minus e raised to the e to the x minus 1 power. Subtract 2. So y is equal to plus or minus e raised to the e to the x minus 1 minus 2. Okay, so again, we run into that situation. Which one is it, plus or minus? Okay, so this is where we're going to check our initial condition. So if we check our initial condition, so y is equal to, I'm going to do the positive one first, e raised to the e to the 0 minus 1 minus 2. Oh, wait, y, what was y? My bad. Negative 1. Now, this is why you guys need to check, because I already heard some of you guys say it's going to be the negative 1. Is it? So let's check. What is e to the 0? 1. What's 1 minus 1? 0. What is e to the 0? 1. And then what's 1 minus 2? Negative 1. Check. So only one of them is going to work. So which one is it? The positive or the negative? And by positive or negative, I mean this. Which one was this? Positive or negative? positive, okay? So I don't even need to check the negative one because we just showed that the positive one worked. So that means y is equal to e raised to the e to the x minus 1 minus 2.